right, and I'm back, your digital teacher. And since you're here too, I assume that you've been having fun the last couple of days. I think you're going to like this one. Lesson 12.5 is on recursive formulas and iterations. So at the very beginning of the chapter, when we would write down terms, and after the first couple were generated from the formula, then you were able to do it on your own from then without going back to the formula. That was recursive. That's when you just look at the last term and figure out what the next term is going to be. So if we take a look at what we were doing before, which was explicit, then the a sub n rule generates any term from any place in the sequence. Okay, so generates any term from any place in the sequence. Which is kind of nice. So if you need the a sub n or the a sub 25th term, then you plug in a sub 25 into the formula and you're able to get that. Okay, with a recursive, the a sub n rule generates the next term, based on the last term. And when you figure out the pattern and run with it, that's what you're doing. You're just going from term to term to term. You're not going back to the formula. So sometimes this is a lot easier to do. All right, so for example, if we have a really difficult sequence of 2, 4, 6, 8, and that gives us a rule of a sub n equals 2n. All right, so then we could say a sub 1 and put the 1 in for the n, so 2 times 1 is going to be 2. Okay, then if we put the 2 in, okay, we go back to our formula and we say 2 times 2 is equal to 4. Okay, and then we go to the a sub 3 and we take, and now I know you already know what the next one is going to be, but we're using the formula right now. This is what explicit formulas are. So we take our 3, we plug it back in for n, and 2 times 3 is going to give us 6. Okay, so explicitly we're going back to the rule each time. The upside of this is that if we weren't going in order, if we wanted a sub 20, we could say 2 times 20, and that would be 40. Okay, so we would have our rule for that. Okay, now let's take a look at the recursive situation. With a recursive rule, you're told what your first term is and how to get the next term. So our first term is 2, so we take our 2 and add 2 to it. Okay, so our a sub 2 is going to be the last term, which was a sub 1, and plus 2. So 2 plus 2 equals 4. Then a sub 3, we take the last term, we say 4 plus 2 equals 6. Okay, now let's say we wanted a sub 20. Okay, now we need the last term, which is 19. And to get 19, we need the 18th term. So if you're going recursively, you have to go in order. You can't skip around and go from the middle. So that's one of the downsides of the recursive. The upside is that if you are going in order, it's easier because you follow the pattern and it's boom, 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 and you've got it. Okay, so let's take a look at the difference between the explicit and the recursive in both arithmetic and geometric. Okay, so our a sub n formula in arithmetic is a sub n equals a sub 1 plus n minus 1 times our common difference. Okay, our geometric formula is a sub n equals a sub 1 times the ratio to the n minus 1. And this is another one that we can start in the middle, we can start at the end. We don't have to go in order for that because it's an explicit one. We put in the term number that we want and we simplify it. Okay, recursively, we have to go term by term by term. So this one is going to be a sub n equals a sub n minus 1, which means the term before. So if we're looking for the third term, then this would be 3 minus 1. We would have to start with the second term plus the difference. Okay, and it works the same way with the geometric. In order to find the a sub n term, we would start with the a sub n minus 1. And n minus 1 means the term before. So if this is a sub 6, then we would want 6 minus 1, so we have to start with a sub 5. And then times our ratio. Okay, so let's take a look at some recursive examples. So you're always given your starting term. You have to have the starting term because it takes that one in order to get the next term. So we have the next term equals the starting term plus 5. Okay, so a sub 2 is a sub 1 plus 5. So 3 plus 5, which equals 8. Okay, then a sub 3 is going to be a sub 2, which was 8, plus 5. Okay, 8 plus 5 equals 13. A sub 4 is going to be a sub 3, which is 13, plus 5, which equals 18. Okay, see how that works? You're starting with the last term in order to get the next term. Okay, let's take a look at another example. All right, so this one, we're given a sub 5, and we want 2 times a sub n minus 2. Okay, a sub n minus 2, that's 2 back. Let's go ahead and change that to n minus 1. Okay, so that should be n minus 1 because we can do that, but we have to have a sub 2 also, and we're going to do that in just a minute. Okay, so we have our first term is 5, so we're going to say 2 times the last term, so 2 times 5 is equal to 10. Okay, for our a sub 3, we want a sub 2 times 2. So now we're going to say 2 times 10, which equals 20. Okay, then a sub 4 is going to be 2 times the last term, which was 20, which is now 40. Okay, so you take the last term and apply it to find the next term. All right, let's flip this over and take a look at a couple more examples. And this is going to bother me unless it all matches, so I'll just go ahead and fix that real quick. Okay, so example 4, we have a sub 1 is 2, and our rule is the term number squared plus 3 times the last term. Okay, n minus 1 is always the last term, so for a sub 2, the last term is going to be a sub 1. All right, so for a sub 2, we want 2 squared, okay, plus 3 times the last term. Okay, so the last term was a sub 1, so 3 times 2. So we have 4 plus 6 is 10. Okay, a sub 3. Now we want 3 squared plus 3 times the last term. The last term was 10. So it's going to be 3 squared is 9 plus 30. So we get 39. Okay, now for the fourth term, it's n squared, so 4 squared, plus 4 times, 3 times the last term, which was 39. Okay, and that's going to be 3 times 39 plus 16, which is going to be 133. Okay, so to find this sequence, you take the term number squared and 3 times the last term. N minus 1 is always the last term, or the term before. Okay, now, I told you a couple examples ago that it was possible to have n minus 2. Not without being given another term, though. Okay, so we already said that n minus 1 is the term before. N minus 2 is 2 terms before. So if that's going to be the case, then we have to be given 2 terms. Okay, and in this case we are. We have a sub 1 equals 1 and a sub 2 equals 2. And then we can plug them in. Okay, so this one, a sub n minus 2, is going to be 2 terms before. And for a sub 3, 2 terms before would be a sub 1. So we're going to say 2 times a sub 1 plus 3 Now this is the term before. So since we're doing a sub 3, that means a sub 2. Okay, and sometimes I write it out this way just so that I can get a feel for what this rule is. So a sub 1 and a sub 2. So 2 times a sub 1 is going to be 2, plus 3 times a sub 2 is going to be 6. So I'm left with 8. Okay, so let's try this again. A sub 4. So now I want 2 terms before, so that's going to be 2 times a sub 2 plus 3 times a sub 3, which I just found, which is the last term. Okay, so 2 times a sub 2 is going to be 4, plus 3 times a sub 3 is going to be 24, which equals 28. Okay, now a sub 5. I want 2 terms before, so that means 2 times a sub 3, plus 3 times the last term, which is a sub 4. Okay, so 2 times a sub 3, so 2 times 8 is 16, plus 3 times a sub 4, so 3 times 28, which is 84. And then when we add those together, we get 100. Okay, so sometimes these recursive formulas can be more complicated than what the explicit formulas are. And it also allows you to come up with more complicated formulas than what you could in the explicit ones. Okay, so the last thing that we're going to cover is iterations. And normally it kind of builds until the very hardest part. But this is not the case with iterations. Iterations are the mathematical rules that create fractals. And we're going to talk about fractals on Monday because we're going to do a fractal lab on Monday. But iterations are repetitions. Okay, so if you iterate something or reiterate something, then you're going back over what you did before. Okay, so that's what this is. Only in math, our first term is going to be x sub 0, and that's our given. And so then when we want to find the first 3 iterates, we're looking at x sub 1, x sub 2, and x sub 3. And we don't use the a sub n's anymore. With iterations, it's always the x's. So we're going to start with x sub 0, which is negative 4. And we're going to put a negative 4 in here. So that means that 2 times negative 4 plus 5. Okay? So 2 times negative 4 plus 5, equals negative 8 plus 5, which is negative 3. Okay, now for the next one, we put in whatever we got for the last one. So this is like an a sub n minus 1. Okay, so we're going to say 2 times negative 3 plus 5 equals, and 2 times negative 3 is negative 6, plus 5 is negative 1. Okay, last one. We're putting in the last term, so 2 times negative 1 plus 5 is equal to negative 2 plus 5, which is 3. Okay, so when we find the first 3 iterates, we're looking at negative 3, negative 1, and positive 3. And that's going to be our solution for that. All right, so with iterates, the difference is you start with a given, and then you find the first 3. And when you find the first 3, you're substituting in the last one each time that you found, starting with whatever the given was. Okay, any questions? All right, I think you'll find this fairly self-explanatory. So don't forget, tomorrow there's a quiz, and it's over everything in this chapter, but you will be allowed to take it home and work on it, as long as you're working on it in class. If you are blowing it off in class, then I will instruct the substitute to make it due at the end of the period. Okay? All right, see you on Monday.